Hello all, welcome to the Mechanical Engineer. In this video, we are going to solve another problem on the equilibrium of particles. So the problem is a sack hanging at A weighs 400 Newton. Determine the weight of the sack at D and the tension in each rope to keep the system in equilibrium. So in the problem, it is clearly said that the system should be in equilibrium, which means that the resultant is equal to 0. Now coming to the drawing, so here two main points are there. One is point B. In point B, we have two strings and a weight. So here you have a BF string, here you have BC, and you have a weight 400 Newton. Similarly, coming to the next point C, we have a string CB and CE. Also, we have a weight D. So our objective is to find out the weight of the sack D and also the tension in each strings. So first step, we have to draw the free body diagram. So let us draw the free body diagram starting from the point B. So I am first considering the point B. Okay, fine. So in point B, a tension BF is acting like this. So it is T. From B to F it is acting. So it is TBF. Then a weight of 400 Newton is acting in the downward direction. So it is 400 Newton. And also a tension TBC is acting like this. So from B it is acting to C. Now, there are three forces are there. So we can use Lamis theorem if we know the angle between all the forces. Let us write the angles directly given. So here the angle is given as 30 degree and here the angle is not directly given. Instead, the lengths are given. So you can write theta is equal to tan inverse of 3 by 3. That will give you 45 degree. Okay. So now if this is 45 degree and the remaining angle is 30 degree, then the overall angle will be 45 plus 90, it is 135 degree. Similarly, here also we have 30 degree and a 90 degree here. So the summation will be 90 plus 30, that is equal to 120 degree. Now at the top, so this line is 180 degree. So here we have 30 degree and we have 45 degree here. So it is 180 minus 30 minus 45 will give the remaining length, the remaining inclination, that is 105 degree. Okay, so first let us start with this point, then we can draw the free body diagram for point C. So I am going to use the Lamis principle. So I am starting with the known force. It is 400 divided by sine of other two forces. It is sine 105. That is equal to, first I am going to substitute TBF divided by sine of other two forces. It is 120 degree. So remember that when you are writing 400 Newton, you should take the angle between the other two forces, that is 105. So when you are writing TBF, you should take the angle between other two forces, that is 400 and TBC, that is 120 degree. Further I can write TBF is equal to 400 divided by sine 105 into sine 120 degree. So if we solve this, then we will get the value for TBF as 358.7 Newton. Okay. Now let us write for the next force. So that is 400 divided by sine 105, that is equal to TBC divided by the other two forces. The angle between other two forces is sine 135. From this I can write TBC is equal to 400 divided by sine 105 into sine 135, that is equal to 292.8 Newton. Okay, so this is TBC and we know that the TBC is same as TCB. Okay, so with this now let us draw the free body diagram for the point C. Now consider point C. Okay, So from C, a tension of TCB is acting like this. Similarly, another tension TCE is CE is acting in the upward direction, and the WD is acting in the downward direction. So we can use the Lamis theorem here because we have three forces. So first, the 45 degree is directly given, and also here the inclination between the string and the horizontal line is given as 30 degree. So if this is 30 degree, then this inclination is also 30 degree. So I can write 30 degree here. Okay, now the overall angle is 90 degree, and this 90 minus 30 degree is 60 degree. So here the remaining inclination is 60 degree. Similarly here it is 90 plus 90 plus 45 degree. So that is 135 degree. Now the remaining angle is 360 degree minus 135 minus 60, that is equal to 165 degree. So now we know the angle between all the forces. We can write the Lamis theorem now. So I am starting from the known force because from the previous Lamis theorem we have found out the value of TCB because TBC is same as the value of TCB. So I know the magnitude of TCB, that is equal to 292.8 Newton. So I am proceeding with the known force, that is 292.8 divided by the sign of other two forces. So between TC and WD, it is sine 135. So that is equal to WD divided by sine 165. So from this, we can write WD is equal to 292.8 divided by sine 135 into sine 165. So if we solve this, we will get the WD is equal to 107.2 Newton. So this is the weight of the sac D. Now to calculate TCE, I can write 292.8 divided by sine 135 because that is the known force divided by TCE divided by, so when you are considering TCE, the angle between other two forces is 60 degree. So it is sine 60 degree. So further, TCE is equal to 292.8 divided by sine 135 into sine 60 degree. So if we solve this, then we will get TCE is equal to 358.6 Newton. Okay, fine. So in the problem, first we have drawn the free body diagram and we have started with the known force. So the 400 Newton is given. So we have started from the 400 Newton and calculated the tension for other two strings. And we know that TBC is same as TCB because both are same strings. So now TCB is our known force. So by considering point C, with the help of TCB, I have calculated TCE and WD. Thank you.